Transmission line. Do you know how transmission is done from set-top box or antenna to television? It is through transmission line, typically of coaxial type. Now, let's see what exactly these coaxial cables are. It consists of 4 layers. Innermost is conducting wire. This is one of the conductor that is required for transmission. Second is the insulation. Third is the copper mesh shield, which is second conductor required for transmission, while fourth one is outer insulation. The second layer provides insulation between conductor and copper mesh shield, while fourth layer, that is the outermost layer, provides insulation between conductor and human. The transmission takes place through 2 conductors, namely, conducting copper wire and copper mesh shield, and hence the input and load is connected at the 2 terminal of coaxial cable across these 2 conductors as shown in animation. Now let's see how actual transmission takes place. Transmission line is electric line. It transmits electric energy or power from one point to another point, that is, from source to load. It is mostly used for higher frequency up to 3 GHz. Let's look at basic construction of transmission line. It mainly consists of 2 conductor structure and the current flows along the structure. Few examples are telephone line and electric transmission line. Consider 2 conductors, namely AB and A raised to 1, B raised to 1, and each of length L. The voltage source is applied at A raised to 1 end and load is connected at B raised to 1 terminal. We have applied sinusoidal voltage of frequency F at input. Consider Vp voltage, which is transmitted at time t1, but Vp doesn't occur at the output terminal at the same instant. There is always delay. It will always require a finite delay to appear at the other end. Suppose Vq voltage is transmitted at the time t2. Then at that instant of time, that is t2, we get output voltage Vp. This finite delay is called transit time, Tr. This transit time is dependent on the length of wire. If the length is reduced, then the delay also decreases with it. Thus the delay is directly proportional to the length of the conductor, mostly considered at very high frequency. Now, when there are no visible element in transmission cable, why there is delay at the output terminal? Let's see why transit time appear. When current flows through conductor, magnetic field is produced along the conductor and electric field is produced between 2 conductors. Inductance. When conductor carries current, flux is generated, which depends on magnitude of current. This flux leakage gives rise to effect inductance. It is denoted by L and its unit is Henry per unit length. Parallel conductor separated by insulating dielectric produces capacitive effect. Due to this, there exists capacitance associated with transmission line, denoted by C, and its unit is farad per unit length. Resistance depends on cross-sectional area of conductors. It is uniformly distributed along the length of line. Total value depends on overall length of transmission line. It is denoted by R and unit is ohm per unit length. As dielectric between conductors is not perfect, small leakage current flows through it. This gives rise to leakage conductance between the conductor. denoted by G, and unit is ohm per unit length. These are the primary constant of transmission line measured in terms of per unit length. Let's see what are the types of transmission line. 1. Coaxial cable. 2. Parallel line. 3. Microstrip line. 4. Balanced line. 1. Coaxial cable we have discussed earlier. 2. Parallel line. It was mostly used in earlier days when we used to watch Doordarshan. 3. Microstrip line. It is mostly used in PCB designing. Balanced line. This is mostly used to reduce some external noise. Mostly used in microphone and telephone to reduce external noise.